Okay, so the first question we're going to take a look at is solving a triangle. When we're using law of sines and cosines, remember that for law of sines, there are three different kinds of triangles you can use that on. Angle, side, angle. Let's see, angle, angle, side. And side, side, angle. On the last test, we focused mostly on angle, side, angle, and angle, angle, side. We didn't get into side, side, angle a lot. So this test is going to cover a lot of that. Okay, so under this, remember you've got 0, 1, or 2 solutions. Okay. So you could potentially see any of those kinds of problems on the test. But let's start with this one and see what happens. All right, do you remember how you can figure out that what kind of problem this is without drawing it and just looking at the table?
Is it, what do you mean, like one of the three right there?
Yeah, how could you figure out if it is one of these three just by looking at the way it's laid out in the table?
Take the givens that you have and compare it to those, right? Because we have two sides and one angle, so it'd be side, side, angle.
So it could be side, side, angle, but how do we know it's not side, angle, side?
Is it because we have B and C and not A and C data?
So what you're looking for in the table is a full row. If you have a row that has everything in it, then that is a law of sines problem.
Okay.
So we have a row that's completely full. That's how we can tell we need to use law of sines on it. All right, what do you have to solve for first?
Gamma.
Right, so we don't have any other choice. We got to find gamma first. So let's set up our law of sines to find gamma. So sine, sine. All right, and what would go on the left side when we're setting it up to find gamma?
Sine 20 over 4.
Okay, good. So sine 20 over 4 equals?
Sine gamma over 6.
Over 6. Okay, so now we've got it set up. What do we have to multiply both sides by?
Give me that side.
What do we have to multiply both sides by?
Like do the cross multiply or before?
Well, we're just trying to get sine gamma by itself, so we don't really need to
multiply
cross
each side by 6.
Yeah.
Right.
I would just multiply each side by 6. 20 over 4 equals sine gamma. And what's our last step to get gamma?
Take the inverse side of each side.
Yep. Take the inverse sine. Do that on the left. Do it on the right. And now we need the inverse sine of, let me change to degrees first. Inverse sine of 6 sine 20 divided by 4. Okay, make sure that you type it in and close the parentheses where I did. Okay, and when you typed it in, did you get, you need to actually do inverse sine. That would help.
That'll do it, yeah.
And did you get that for an answer?
Yes.
Okay, so 30.866. So because we got a solution, we know this is not a no solution problem. We just got a solution.
Yeah.
So 30.866. Okay, and that's for gamma. If there's going to be a second answer to this problem, what do we have to subtract it from?
180.
180. So let's do 180 minus that last answer. If there's a second answer, it's 149.134. But before we write that answer down, we have to see if that angle fits in the triangle. What was the angle we were given?
20.
20. Can you fit a 20 and 149 together in the same triangle?
Yes.
Yes. What do they add? What does that add up to?
169.
and that's not more than 180.
Yeah.
So we have to write that down as a second answer. So this is going to be a 2-solution problem. So now we're going to call this gamma 1, and we're going to call this angle gamma 2, 149.134. Now, since gamma has 2 answers, what else does that mean?
One second, I'm just reading that. Will C have, C have 2 answers?
Nope, C was given, so we don't have to worry about C having 2 answers. Alpha will have 2 answers. Yeah. Yep. And anything else?
A.
A will also have 2 answers. Yep. Okay, so let's start by finishing off the angles, and then we can finish off the sides. All right, so to find alpha 1, what would I add together and then subtract from 180?
30.866 and 20, and then subtract that from 180.
Yep, so 30 plus 30.866, add those together and subtract from 180, and that is alpha 1, 129.134. All right, and now how about to find alpha 2?
149.134 and 20.
Okay.
Subtract from 180.
So subtract that, so that's going to just be, since it's 20, we can just add 169.134. Right, and that's going to give me 10.866. All right, now I don't have a completely empty row anymore, so now I can finally figure out A. So let's start with A1. So to find A1, I'm going to put sine equals sine. And what would go on the left side?
Sine 20 over 4.
Yep. Use that again. So 20 over 4. And the right side?
Would it be sine 129.134 over A1?
129.134 over A1. Yeah, perfect. 129.134, right?
Yes.
Okay. So now, to solve that, that's a proportion, and what do we always do?
Is this one cross multiply?
Yep. Good. So
Yeah,
yeah.
that's fine.
4 sine 129.134, and then you're going to have to divide by the sine of 20. So that should give you about 9.072. Is that, excuse me, similar to what you got?
Yes.
Okay, so 9.072, that's A1. And now we have to find A2. All right, let's set that up. Sine. All right, what's going to go on the left side to
Sine
find
20 over
A2?
4.
Yep, same thing again. Okay, and on the right side?
Sine 10.866 over A2.
Sine 10.66. So the only difference between finding A1 and A2 is the number in the top on the right-hand side.
Yeah. So
if I bring up the last thing I typed in, all I have to do is change 129.134 to 10.866, just like that. All right, and that gives us 2.205. All right, any question on solving that with law of science? Okay. All right, so let's try one more. So for this one, are we going to use law of sines or law of cosines?
Law of sines.
Okay, and what about the table tells you that it's law of sines?
The full row.
Yes, we got a full row in the table. That's law of sines. And what do we have to find first?
Beta.
Okay, so let's set it up to find beta. Okay, what's going to go on the left?
Sine 60 over 4.
60 over 4, yeah, perfect. And on the right?
Sine beta over 5.
Beta 5, looks good. Okay, and now to get sine beta by itself, what are you going to do on both sides?
Multiply each side by 5.
Multiply each side by 5. Okay. And our last step, and we will be able to try to solve it.
Take the inverse side.
Take the inverse. Now, if we just check 5 sine 60 and divide it by 4, oops, 5 sine 60. So 5 sine 60 and then divide by 4. We get 1.08. When you take inverse sine of something, what two numbers does it have to be between?
0 and 1.
It can go up to 1, but it can go lower than 0.
Oh, is it negative 1?
Negative 1.
Yeah.
Okay, is that number between negative 1 and 1?
Doesn't look.
No. So when you try to take the inverse sine of that number, it's not going to work.
Yeah.
And that means this is a no solution. Okay. So this is a no solution. So if it asked you how many triangles could you form with the information given, the answer would be none. You cannot make a triangle out of that information.
Can sine, is it equal to 1, negative? Like, could you take the side of 1 or negative 1?
Yes.
Okay.
Yep. And it would be an answer on a quadrant, like a 0, 90, 180, 27.
Yeah.
Yep. Okay. Any question on that?
No?
So here's another problem where they're asking us to solve. Now, looking at the table, is this one going to be law of sines or law of cosines?
Law of cosines?
Yeah, this is law of cosines. How do you know that looking at the table?
Because there's not a full row.
Yeah, there's not a full row. You have two sides and an angle, and if you were to draw it out, this is side angle side, which falls under law of cosines. Do you remember the one other kind of problem that falls under law of cosines?
Side, side, side?
Yes, side, side, side also does. Now, I'm not going to go through a side, side, side because when you know a side, and a side, all you're doing is finding angles 3 times. In this problem, you're going to have to do both. You're going to have to find a side one time, and then you're going to have to find an angle the other time. So this kind of covers everything that can happen. All right, so with side angle side, you do have to find something first. Do you remember what we have to do first?
I do not.
So every version of the law of cosines has all the sides in it. No matter what version you use, the A, the B, and the C are going to be in all of them. So you're already missing the A. So you can't be missing anything else. So you have to take advantage of the law of cosines that's going to use this angle. Okay, if we don't use that angle, we're going to be stuck. So what law of cosines has alpha in it? How does that one start?
I don't remember, I'm sorry.
Do you remember, well, I'll give you a hint. It starts out with a squared. Can you tell me the rest of that?
I have no idea.
So it starts out a squared, and it's kind of like Pythagorean theorem. But it's not exactly the same letters.
Yeah. Would it be a squared equals b squared?
B squared?
Plus, wouldn't be c squared.
C squared, so that's the first part. Now you have to subtract something. Minus, and there's a number that goes there. No, nothing to do with like
Okay.
180 or 360. Minus 2 times the product of the two sides you just used, the b and the c, times the cosine of a certain angle. And what angle would that be?
Beta in this case.
Well, we don't know beta,
Oh,
so
okay, alpha.
yeah, it would have to be
Sorry.
alpha because it's always the angle across from the side you started the formula.
Okay, I got you.
All right, now we fill everything in. So let's do that. Okay, what's b squared going to be? 1. 1 and c squared?
9.
9. And then what's 2 times b times c?
6.
Yep. So 6 times cosine of, and we know alpha is 8. Okay. What can I do on the right-hand side now?
Like terms.
Yep.
Combine like terms. That's what it is.
And what are my like terms?
1, 9, and negative 6.
Just 1 plus 9.
Just 1, 9.
Because that 6 is
would be-
multiplied.
Okay, I got you.
Yep. So what is 1 plus 9?
10.
10. So you can't subtract 6 because that has to be multiplied by cosine 80.
Yeah.
So we're going to pretty much leave it like that. I just, at this point, I want to get a by itself. So what would a be?
Like what would it equal?
Yeah.
Would it be square root of 10 minus 6 cosine 80?
Yep. And there's no rounding there. That's exact. So we've done good at this point because we haven't rounded anything off. So let's type that in. We are going to round it off. So square root of 10 minus 6 cosine 80. Okay, you should get about 2.993. Okay, so now that's A. Don't have to worry about a second answer. It never happens with side angle side. It's impossible. So we got that. Now you can find either beta or gamma. So that's how you do law of cosines to find a side. Now we have to do law of cosines to find an angle. Doesn't matter which angle we pick. So which angle do you want to find?
Beta.
Beta? All right. So to find beta, what's the law of cosines going to look like that has beta at the end?
B squared equals a squared plus c squared minus 2ac times cosine beta.
Perfect.
Sweet.
Okay, now we got to fill it all in. Okay, we will need a calculator to do some of this. We can do b squared now. What's that?
B squared is 1.
1. What is a squared? Well, actually that we don't know. If we type in, or if we take the answer we just had and just square it, that's a squared.
Yeah.
8.958. So try to do as little rounding as possible. All right, c squared is how much?
9.
That's 9. Now I need 2 times a times c. Well, what's 2 times c?
6.
6. And I need it times a. So 2.993 times, what did we say, 6?
Yeah.
So we should get about 17.958. Okay, going to 3 decimal places, we should definitely be accurate to at least, 1 or 2.
Yeah.
We should be pretty close. 17.958. And that's times the cosine of, what angle are we doing? Beta. Okay. All right, now let's solve it. Okay, what can we do first?
Combine like terms.
What are your like terms there?
8.598 and 9.
Yep. And what's 8 plus 9 give you?
17.
Yes. So 17,598 minus 17. Well, that's a little confusing. 958. cosine beta.
thought they were the same number at first. And I was like,
Yeah, it's a little,
so I
yeah.
can
Okay, what do we do next?
Would we try? Would we subtract 17.598 from each side?
Yep. Subtract 17,598. 17,598. 1 minus 17.958. 1 minus 17.958. Having calculator issues. Okay, so negative 16.958.
It's 0.598, not 958.
Oh,
yeah, that's
That's a mess.
something.
1 minus 17.598. Thank you. Negative 16,598. Hopefully that doesn't happen on the test where the numbers are that close. Okay, so now we got that. Okay, what do we do next?
Would we divide each side by negative 17.958?
Yep, so we're going to divide. So we're going to have 16,598 over 17,958. And since they're both negative, the negatives
Yeah.
are going to cancel. So that's gone. And we can get rid of cosine at the same time. What would we do to get rid of the cosine?
Inverse cosine.
Yep. So inverse cosine. And now we can see what we get.
I'm sorry, I realized I just wrote the wrong number. It's
So divided by 17.958, and hopefully that should come out to 22.442.
these numbers are messing with me.
Okay, so just checking something. When we did a squared, 2.993, and you square it, that's 8.958. So we switched these two digits. I think that was the whole problem.
Yeah.
So you found that, so that's good. So now 8 plus 9 is still 17, but this should be a 958.
Instead of 5.9. Okay.
Yeah.
There it is.
9.5. So fix this so it's a 9.5. And then when you do 1 minus 17.958, again, these two digits are in the wrong spot. 9.5. And we're in the wrong spot again. That's a 9.5. And now, let's see what we get. So the inverse cosine of 16.958 divided by 17.958. And that's what
That's the answer. There it is.
that was a mess. Sorry about that. 19.211. Okay, so that's beta. So 19.211 degrees. Okay, now that we've got beta, the third angle is easy because we can just add up and subtract from 180.
Yes.
Okay, so let's add those together. So we got 80 plus 19.211, and then subtract that from 180. So if our answers are confirming each other, did you get 80.789?
I did.
Okay.
There it is.
So just had to be careful with the 5.9 and the 9.5. That was kind of a mess. All right, but that's a law of cosines problem. And I'm glad you checked it because now everything is correct. All right. Any question on that?
I do actually have a question. So once we find A, is there a reason we still use law of cosine versus law of sine? Like if we were to find beta, we've got alpha, A, and B.
Yeah.
Could we use law of sines to find beta the same way, or would
So
it be different?
you could. The only problem is when you use law of sines, it would be the side-side angle case. And that's the one where you run into the no solution, two solution
Okay.
stuff. So I try to avoid that case whenever I can.
Okay.
So that's why I finished with law of cosines.
Yes, I was just wondering.
Yep. All right, so now we've got a complex number, 3 plus 5i, and they want us to change it to trig form. When you write something in trig form, can you remind me what does that look like?
I'm not sure.
So what do we start with a certain letter on the outside.
We start with I on the outside?
So I is going to be on the inside, but we have something on the outside. It gets distributed when we're converting back the other way. But what are the two things that you need to write something in trig form? You need to know two things.
It's inside the parentheses is cosine and sine, right?
Yeah, so we need
sine first and then I cosine, right?
cosine first.
Okay. Oh, yeah.
So the first thing you got to figure out your angle. That's going to go inside. And there's one more thing you need to know about your point.
I'm not 100% sure what it is.
So if you graph your point, okay, it's going to be 3 to the right, 5 up. The angle, if you think of it on a circle, only tells you the amount of rotation you've done. So if we draw a circle, okay, the angle tells me this. But you could have that amount of rotation in lots of different spots. Okay, it could be any of those. What else do I need to know about this point that tells me it's on a circle that's this big?
Is it the slope? No.
No, it's not the slope. So what would be the difference between a point on this circle or a point on this circle, or if the point was on that circle or that circle? They're all the same amount of rotation. But if they were on circles, they would all have different what?
Degrees. Was it?
Well, the degree is the amount of rotation.
Yeah.
So that's the same. But if you draw in all the other circles, they all have something that's different about them. Like that would be that one. That would be that one. Yeah, that would be that one. So what's different about all those circles?
Just how big they are.
Okay, and how do you measure how big it is?
Oh, radius.
The radius.
That's it.
Okay, so you need to know the radius, and you need to know the angle. Okay, how do we find the radius when you have the point 3 plus 5i?
Would it be finding that the diagonal line you just drew, finding how big that is?
Yeah.
Yeah.
And yeah, how would you find that?
Wouldn't it be Pythagorean theorem?
Yeah.
Yeah.
So you just make a triangle out of it. And how long is the bottom side?
3.
1, 2, 3. Yep, so that's 3 units. And the height
5.
is 5. So the hypotenuse, which is the radius, would be the square root of what number?
34.
Yes. Okay. Not worried about reducing that, even if we could. We'll just look at it. So there's my radius. And now my angle is in quadrant 1. What's the formula that we use to find an angle in quadrant 1?
Is it sine over cosine? I'm not.
Well, you're trying to find this angle from here to here,
Yep.
and you know this side, and you know this side. So what are the names of the two sides that you know?
Oh, opposite over, so it's sine, right?
What are the names of the two sides?
Opposite and adjacent.
Opposite and adjacent. And what trig function has those two?
Tangent.
That's tangent.
That's it. Okay.
So the tangent of theta, which is theta's right here, tangent of my angle would equal what over what?
5/3.
5/3. So then what would my angle equal?
5/3. What was that? No.
So I'm trying to get something that looks like this instead of what I have on the right side.
Would you take the cotangent of 5/3?
No, cotangent doesn't cancel out regular tangent. What function would cancel tangent?
It's right there. I don't remember.
Inverse tangent.
Inverse tangent.
Yeah, you have to take the inverse tangent of each side.
Oh,
That's what I meant when I said cotangent. That was my bad.
So inverse tangent of 5/3. Oops, inverse tangent 5/3. That gives us an angle of 59.036. Okay, so there's our angle. So now, how are we going to write our final answer?
Square root 34 parenthesis cosine 59.036 plus I sine 59.036.
Yep. Okay. So that's how you take something and convert it from standard form to trig form. Now, the next thing is just converting it back the other way. Convert from trig form to standard. Well, let's take the number we just did. How could we take that and change it back to what we started with?
Sorry, I'm still writing this down. Take that and convert it back.
Well, what would be your first step if you wanted to try to do all this out?
Would you put the square root of 34 into the cosine of 59.036 and the I sine of 59.036?
Yeah.
Distribute.
Yep.
That's the word. I just couldn't think of the word for it.
So let's distribute that out. So take the square root of 34 and multiply by the cosine of 59.036. And that gives us basically what number?
3.
3.
Pretty
It's
much.
not exactly 3 because we rounded.
Yeah.
So that's 3 plus, and then what'd you say the next thing was we do?
Distribute it into sine of, or I sine 59.036.
Yeah, and we could just leave that there. So we just need the sine of 59, whoops, so square root of 34 times the sine of 59.036. And what does that give me?
5.
Yeah. So, and there's an I next to it. And that, 3 plus 5i, is exactly what we started with. So we just changed something to trig form, and we just changed it back. Any question on that one? So this one is giving us two complex numbers already in trig form, and they want us to multiply them and divide them. So let's start with multiply. So to multiply these two numbers together, what do we do with the two radii that are in front?
Do we add them together, or do we multiply?
We multiply.
Okay.
So multiply the radii, and what would that give you?
8.
So 8. And what do we do with the two angles?
Do we add those together?
Add those, and that would give you
Cosine 60.
60 plus I sine
60.
60. Yep. And That's it. That's how you multiply them together.
Cool.
Now to divide them, what do we do with our two radii when we want to divide?
Divide them.
Divide them. So the radius would be,
Oh, sorry. 4/2.
yep, which is
Oh, 2.
2.
Oops.
And what about your angle?
Is it still the same as the first two? Right? Like, so would it be 50/10? Or I'm sorry. I'm still writing down the multiplication one.
So not 50/10, but something, how did we get 60?
Adding 50 and 10.
Okay, so it's something kind of like that,
So
except,
subtract
Yeah.
something from 60. Would it be 10 from 60?
well, to do the division, you don't need the multiplication at all. So don't even
Okay.
look at the 60. You're going to look back at the two original problems.
Okay, I got it. So subtract 10 from 50?
Yeah,
Okay.
yeah. And what would your angle be?
40.
40. So that's the stuff
Okay.
that we did pretty much yesterday, multiplying and dividing. All right, so last one we'll look at is finding the cube roots of a complex number. So we'll do the cube roots of 3 plus 7i. Okay, so finding the cube roots. So remember, that means you're basically trying to solve for what number can you raise to the third power and get 3 plus 7i. So what's the first thing we have to do on both sides of that equation? Me too.
Would it be taking the cube root?
Well, we are finding the cube root, but we have to do something on each side of the equation first. What did we do in class with this number and the z?
Do we? You're talking about the 3 or the 7?
Well, this needs to change to something, and
Yeah.
this needs to change to something.
I'm not exactly sure.
You have to change everything to trig form.
Oh, change everything to trig. Okay.
So how would we change the right side to trig form? What do we have to find?
The radius
Radius
and theta.
and theta. Yep. So the radius is going to be the square root of what number?
Would it be 7/3?
So you got to use Pythagorean theorem
Oh yeah.
to find that hypotenuse.
Square root of 58.
Yep. So the radius is the square root of 58. And what quadrant are you in?
The first one.
First one. What's your formula for theta in quadrant 1?
Opposite over adjacent.
So those are the sides it's going to be, but what would be like the trig formula you would write
Tangent.
down? Inverse tangent.
Or inverse tangent, yes.
Of
Would it be 7/3?
7/3.
Yeah.
Okay, so that's going to be our angle, and that's not going to come out to a nice number. So inverse tangent of 7/3. Inverse tangent 7/3, and that's 66.801.
Isn't too bad to get worse.
Okay, so now what are we going to put on the right side?
Square root of 58.
right?
parenthesis cosine 66.801 plus I sine 66.801.
Okay. And now on the left side, we're going to use de Moivre's theorem to write z cubed. But remember, z is going to be replaced with r cosine theta, I sine theta. So what would r cosine theta, I sine theta to the third power be?
Would it just be the same thing on the right, just to the third?
Well, it's going to be all variables, because we're not going to have any numbers on the left-hand side for the radius or the angle.
Yeah, so it would just be variables on the left. So it would be r parenthesis
R to the
third power
r cubed, yeah.
parenthesis cosine
And what's
theta.
And it's cubed, so what's that angle going to be when you cube it?
Like what would the 66 be cubed or?
So you
Sorry.
have to use de Moivre's theorem here to cube. You're doing r cosine theta plus I sine theta,
Right.
all raised to the third power. That's what needs to go right here. And that's the first part. So r cubed cosine,
3, like to the power of 3, or would it just be 3?
3 theta.
3 theta. Oh yeah, I was gonna say theta after. Just to make sure it would be okay. And then I sine 3 theta. Yeah.
Yep.
Okay.
Now you've got to set up two equations.
Just write this down.
What are the two equations we have to set up? Well, what are the two things we have to solve for now?
Cosine 3 theta and sine 3 theta. Or
Well, what are the two unknowns on the left side?
theta and radius.
Theta and radius. So we got to set up an equation to solve for the radius and one to solve for theta.
Okay.
What's your radius on the left?
Would be square root of 58 to the power of 3.
So just looking at the left-hand side, what is your radius? Or how is it represented? It's not a number. So what in this represents your radius?
R.
R cubed.
R cubed.
R cubed is your radius.
Okay.
So your radius on the left needs to equal, what's your radius on the right?
Square root of 58.
Square root of 58.
Okay. I get that.
And what's your angle on the left?
Angle of 66.801.
Left side.
Oh, left. I'm sorry. 3 theta.
3 theta. And the angle on the right?
66.801.
66.801.
Okay.
But you have to add something on the end of that 66.801 so we get all the solutions. What do we have to put on the end of it?
Would it be cube root?
No, plus something.
Something. It wouldn't be I, would it?
No, plus 360n. You have to add that on the end.
Oh, okay.
Now, what are the values of n going to be in this case? Because we're doing a cube root. It's going to be 3 numbers.
Just 3.
What number do we always start with?
0.
Yep. That's the first one.
And then would it be 3
No, we got to go in. They go up by 1.
up by 1? So it would be 1
1, yep.
and then 2.
And 2.
Okay.
So we need to plug in 0, 1, and 2
For n.
for n. All right. So now let's finish off solving for r. So r is going to be, how would you get r by itself there?
cube root, you said?
Yeah, so it's kind of messy.
Yeah.
It's the cube root of the square root, which is the same as the sixth root. Because you could think of it as like 58 to the 1/2 to the 1/3. So it's really the sixth root of 58.
Okay.
Okay, so we got that. So that's my radius. Now, how would we get theta by itself here?
Divide each side by 3.
Yep. And now you've got 66.801 divided by 3, 22.267. Plus what would go on the end of that.
360n.
But you've got to divide it by 3.
Oh. 360n over 3?
So 120.
Okay. I wasn't sure. Okay.
Yeah, I got it.
Now from here, you would write your 3 answers. Every answer would have the same radius, but you'd fill in 0, 1, and 2
Okay.
for n to get your 3 different angles. And that's how you pretty much finish that one up.